So we will look into the chemical properties of period 3 elements. So when we uh, period 3 elements, when they react with oxygen, they will give you the oxide. So for example, sodium with oxygen, they will give you sodium oxide, magnesium oxide, aluminium oxide, silicon oxide. Okay, P4O10, SO2. Okay, when sulfur reacts, it will give you SO3. And the two elements in your period 3 that do not react with oxygen will be chlorine and argon. So there will be no reaction between chlorine and argon. So for this reaction, okay, for sodium oxide is a white solid, and the reaction is going to be vigorous when heated. The reaction is also going to be vigorous when heated when you react with magnesium as well. Okay, but there is a flame. Okay, the flame that we are going to look at is going to be a bright yellow flame for sodium with oxygen. But whereas for magnesium and aluminium, both of them are going to actually burn with a bright white flame. So this is something that we want to take note as well. Okay, for the reaction between aluminium with oxygen, the reaction is considerably slow, but it's supposed to be vigorous. But the problem is aluminium do not react with oxygen because generally aluminium has already reacted with oxygen to give you aluminium oxide, and this aluminium oxide, they will form a protective layer where they are going to make the aluminium oxide aluminium to be not so reactive towards oxygen, because aluminium oxide, they are not reactive towards oxygen, they do not react, so it forms a protective layer. Therefore, okay, the reaction is considerably slow compared to what we expected. But if you really want the reaction to take place, you can use powdered aluminium to increase the total surface area, and you can actually see the reaction, and you can see some sort of a bright flame if you use powdered aluminium. So that is how you increase the rate of reaction. But for silicon, okay, silicon is going to be burned with it's going to be a slow reaction. It is going to be burned with a gentle when ignited. Okay, it will burn gently. But one of the things that we need to know is the flame. The flame is going to be a sorry, this is going to be slow and steady. Sorry, yeah, there is no flame. Yeah, so slow and steady. So the reaction is going to be quite slow. But the reaction with phosphorus and oxygen is going to be vigorous. It will give you either yellow or white flame, and it will form clouds of white products over there. So P4O10 is cloud of white product, and the reaction is going to be vigorous. For sulfur and oxygen, okay, it's going to be when ignited, it will burn gently. But the important thing that we need to know about this reaction is going to be it will give you a blue flame, and it is going to be this SO2 is going to be something that will be toxic. Toxic gas is going to be released. So SO2 is going to be toxic. So the reaction of SO2 with O2 will give you SO3. So this reaction is going to be one of the reaction that we learn in contact process to produce sulfuric acid. So the reaction is going to be reversible, and it is going to be catalyzed by this catalyst vanadium 5 oxide. And then if you want to look into the conditions of the condition of contact process is going to be 450 degrees Celsius, and then the pressure is going to be 1 to 2 atm atmospheric pressure. Okay, 1 to 2 atm, and the catalyst is going to be vanadium 5 oxide, V2O5. Yeah, so there is no reaction with Cl and Ar. So let's actually move on further. The elements do react with chlorine to actually give you the chlorides, except for again argon. They are noble gas, they do not react. So Cl2 do not react with Cl2, so we just leave it over there. So the rest, all of them, they react, but except for this one, for sulfur, okay, they form SCl2 and S2Cl2, but they are not in syllabus, so we are not going to focus on that. But these three reactions, the first three reactions, sodium, magnesium, and aluminium, all of them are vigorous, okay, when heated. Okay, so the reaction is vigorous. For silicon, generally with oxygen and with chlorine, basically the reaction is going to be slow and steady, so similar to just now. But for phosphorus earlier when they react with oxygen, they were vigorous. But now, okay, phosphorus when you react with excess chlorine as well, they are going to be still going to be slow. So this is something that we want to take note over here. Yeah. So all of them, they're generally going to give the chloride. So elements will react with water as well. Okay, they are going to give you the hydroxide, but there are two elements that will react with water. The rest of them, they are not going to react with water when it comes to period 3. Okay, so when we have this sodium reacting with water, they are going to give you sodium hydroxide and hydrogen gas. Okay, so this reaction is going to be vigorous, and this reaction, when it is going to be vigorous, okay, even though when we are using cold water, so this reaction is very vigorous, so we don't even attempt to actually try with hot water. So the reaction, if you are going to react with magnesium and water to give you magnesium hydroxide and hydrogen gas, so what we are going to get is going to be a reaction that is going to be very slow with cold water. So this is going to give you magnesium hydroxide and hydrogen gas. But what if we try this with hot water, or for example, we try this with steam? You are going to have a reaction, and it is definitely going to be vigorous. But the thing is, the product, you are not going to get magnesium hydroxide, you are going to get magnesium oxide. So this is going to be one of the difference that is going to take place over here. So when it comes to these two, okay, both of them, they are going to actually form an alkaline solution. So the pH of sodium hydroxide is going to be pH 14. This pH is going to be pH 11. So you can clearly see that sodium hydroxide is going to be, the pH is 14. So it tells us that if you want to compare, sodium hydroxide is soluble more, okay, to give you more hydroxide ion compared to magnesium hydroxide. So solubility of sodium hydroxide is more compared to magnesium hydroxide. So that explains the difference in the pH as well. Okay, this is going to be for the reaction of element with water. So if you look at the other reaction when it comes to, for example, the reaction of oxides, okay, of period 3 elements. Okay, so we do have, for example, if you have these oxides of period 3 elements, all sodium oxide, okay, they do react with water. Okay, they do react with water to give you sodium hydroxide, similar like just now. Okay, sodium react with water to give you sodium hydroxide. Sodium oxide also do react the same. The same thing applies to magnesium oxide as well. They give you magnesium hydroxide, but the difference is they are not going to give you the hydrogen gas like just now. The pH is still going to be the same, pH 14, pH 11. Okay, and we can see that like for magnesium oxide and magnesium hydroxide, when you have indigestion problems, okay, basically in our stomach, we have this indigestion problems because you have excess of hydrochloric acid. So we need to figure a way how to neutralize the hydrochloric acid. So magnesium oxide and magnesium hydroxide can be used to neutralize the excess acid over there. So this is going to be the reaction that is going to be involved. Yeah, it will give you the salt and water. It's a neutralization reaction. So this sodium oxide and magnesium oxide, we call it as a basic oxide because metal oxides, they are generally basic oxides. They react with acid. Okay, so it's basic oxide. And when it comes to Al2O3, there is no reaction with water. But Al2O3, they are amphoteric. So they do react with acid. They do react with base. Okay, so it gives you aluminium sulfate and water. So it gives you NaAlOH4. So there is a reaction. Okay, so there are two reactions. So we call it as amphoteric. It can react with both base. It can react with acid, but there is no reaction with water. SiO2, there is no reaction with water, but do remember SiO2 is considered to be non-metal, so they are acidic oxides. So all these are acidic oxides. Okay, so SiO2, P4O10, SO2, SO3, they are acidic oxides. So they can react with the hot concentrated alkali, but they cannot react with the acid because they are not amphoteric. Yeah. So the reactions, okay, generally, like for example, no reaction with water, but Si, yeah, but they do react with sodium hydroxide. But P4O10, okay, they do react with water to give you phosphoric acid. SO2 do react with water, sulfurous acid. SO3, they do react with water to give you H2SO4. So all of them, okay, they do react with water except, okay, for aluminium oxide and silicon oxide. Okay, so all these reactions are very important. So when we look into this acid-base nature, you can see basic, these two are basic, amphoteric aluminium oxide, then the rest of them are acidic. And you can see as well, okay, the relative melting point. The melting point is going to increase, okay, generally because the metallic bonding is getting higher. And then you can see very high over here because it's a giant covalent molecule, and very low because simple molecule. Electrical conductivity, yeah, because they have more electrons given to the clouds of electrons, they clouds of delocalized electrons, so they increase. Okay, but here electrical conductivity is no electrical conductivity. Ionic with covalent character, we will discuss this in A2, and all of them are covalent. And you see generally ionic, they form giant ionic, so all these are giant ionic, giant covalent, simple molecular. Okay, and then when we look at the last one, which is going to be chlorides. Okay, all chlorides, okay, generally when you have chlorides, okay, these two are going to be actually to be three, yeah, three including aluminum, supposed to be metal chloride. Okay, but these two, sodium and magnesium chlorides, they ionizes in water. So basically when we use the term ionizes, they change into ion. Okay, they change into ion. So we cannot say they react, they do actually ionize in water, they dissolve in water. But Al2Cl6, they can be ionic, okay, if it is going to be in form of AlCl3 with the presence of water. So they do present in giant lattice form, but it can be also in covalent, which is going to be in the dimer form, which is Al2Cl6, but this one is without water. So it can be covalent without the presence of water. But if there is water being added, what happened? The dimer is going to be broken. So you have Al3 plus and Cl minus. Okay, but once you get that, it will immediately form bonds, okay, with water. It gives you this Al H2O6, okay, that is going to be Al3 plus, they exist in this form, and they are going to hydrolyze, okay, to give you H plus, okay, and forming this structure. So you are going to have this, we can say that aluminium chloride with the presence of water is going to be acidic. So therefore, okay, we can say that this is going to be forming a acidic solution. So when it is acidic, please take note that this H plus and the Cl minus that you have earlier, they can combine to give you HCl. So in this case, if you look at the reaction, all of them, okay, even here, when we say hydrolyze, even including aluminium, okay, they will hydrolyze in water, okay, to give you HCl. You can see SiCl2, they will give you HCl over here. And then PCl5, they react and give you HCl over here. And this is not in syllabus, so generally they do give you HCl as well, the white fume of HCl, hydrogen chloride. So do remember, aluminium, silicon, phosphorus, and sulfur, all the chlorides, they do give HCl when they are reacted with water, when they hydrolyze in water. So this is going to be something that you need to take note. The important thing is related to aluminium chloride. So you need to know what is going to happen over here. Okay, thank you everyone.